Greetings, students. Mr. Harrison here. We just finished up doing Screencastify and you watching a video of the phases of matter. Now I wanted to look at phase changes or state changes in matter. And this is a key quote for this. Energy determines the state. Because we talked about how higher energy is going to be towards the top here and lower energy is going to be towards the bottom with solids. So let's dive in on phase changes. So here's a couple rules you got to know. First one, when energy is added, particles move faster. Kind of seems like a no-duh statement, but we have to say it just in case people might not think about it that way. When energy is added, particles move faster. Now this is going to blow your mind. When energy is taken away, particles move slower. Duh, right? It's the opposite of this one. So adding energy, faster. Taking energy away, slower. So we have a solid, and I want you to think of these next couple things in terms of water. So solid water would be ice, right? So with this water, looks like it's being heated up, right? It's going to turn into a liquid. Why? Well, we'll figure it out here before we're done. Anybody ever held a chocolate in their hand for a little too long? And then you end up with the chocolate puddle? Same kind of concept, right? This water puddle in the ground, if it's left out in the sun all day, is it going to be there at the end of the day? Probably not. Something's going to happen to it. And then lastly, the infamous slow-eating ice cream cone person. It's going to end up with a big, big mess. I know my little kids end up with a big mess more often than not. And then lastly, this guy he's got liquid metal, like melted steel. What's going to happen to it as it cools? Right? So when you've got a solid and you add energy to that solid, the solid becomes a liquid. So think of ice. You take solid ice, add heat energy to it. It's going to become a liquid. This process is called melting. Most of you, if you think about ice, you know that ice melts, right? If it heats up. So that's the name of the phase change. It's called melting. Second one, if you take a liquid, so think of like liquid water, and you add heat energy, that liquid will become a gas. So in the case of water, it becomes water vapor or steam. And this process is called one of three names. We only listed two, but it's called evaporation or boiling. Sometimes evaporation for short is called vaporization. It's not really shorter, but it's a different name that means the same thing. Evaporation, vaporization, or boiling. And evaporation and vaporization both have the word vapor in them because it turns it into water vapor if it's water. That's a liquid being heated up, turning into a gas, evaporating or boiling. When you take energy away from a liquid, so you got liquid water, and you take heat energy away from it, it becomes colder, right? So that colder water is going to turn into solid water, which is called ice. And that process of a liquid turning into a solid when it's cooled down is called freezing. That's why your ice is made in the freezer. When energy is taken away from a gas, that means the heat energy is being taken away, therefore the gas is cooling down, it's getting colder. That gas can become a liquid, and this process is called condensation. So gases being cooled and becoming liquids is called condensation. And this is what you see if you've got a cold beverage outside on a hot summer day, especially if it's humid. That water vapor in the air will cause that cold beverage to start to look like it's sweating, but in reality, it's just the water vapor cooling down on the outside of the bottle and becoming liquid water again, which will in turn drip down the sides of the bottle. It's that refreshing look on all the commercials. That's due to condensation as gases are cooled and become liquids. Now, there's something that happens when we do these processes quickly. So if we take a solid like ice and we rapidly heat it, we add heat energy to it a lot, it can actually skip the liquid stage and go straight from a solid into a gas. And this is called sublimation. You've all seen this, believe it or not. If you in Winchester specifically, a lot of times we'll get a big snowfall, and then like a day or two later, it'll be like 50 degrees or something, like really warm. And in Fahrenheit, remember we use Celsius for the metric system for the SI units, but in customary units that we use for our weather here, we use the Fahrenheit scale. And in the Fahrenheit scale, 32 degrees is freezing and melting. So 50 is way hotter than that. So what happens is you can literally look outside in the sunlight and see the snowbank steaming. That is solid ice or snow turning straight into a gas, skipping the liquids. We like to put it in Twitter terms, and we say this is the hashtag left out liquids club. Hashtag left out liquids. And that's turning straight from a solid to a gas, skipping the left out liquids. And that's called sublimation. This is also what happens with dry ice. When dry ice rapidly becomes that gas, carbon dioxide, that is a process called sublimation. That's why it's called dry ice, because it skips the liquid stage. Hashtag left out liquids. Now, opposite's also possible. When a gas is rapidly cooled, or you take the heat energy away from a gas very, very quickly, it can also skip the liquid stage and turn straight into a solid. And this process of a gas turning straight into a solid is called deposition. It's basically the opposite of sublimation. Sublimation is a solid turning straight into a gas, skipping the liquids, hashtag left out liquids. Deposition is the gas skipping the liquids, hashtag left out liquids, and turning straight into a solid, and it's called deposition. I think of it as terms of it deposits a solid. So here's the $1 million question for you right now. Did we get something new here in each of these? First one, ice cream and melted ice cream. Is it something new, or is it still ice cream? If you think about it, ice cream melting is still ice cream. It's not a new substance. Keep that in mind for later. Second one, chocolate and melted chocolate. Is it still chocolate? Why, yes, it is. It's still yummy and delicious. It's just much more messy. Doesn't change taste. It's clearly still chocolate. Next one, ice into water and then water into water vapor. Is it still water? Yes, it is. It's just in a different form or different phase. And the last one, steel and molten steel. Is it still steel? Yes, it is. And the reason for that is because when we talk about physical and chemical changes, the whole determining factor is whether we've created something new or whether it's the same thing. So what I'm telling you here is phase changes are all physical changes. I'm emphasizing the sound for you to learn it. Phase changes are all physical changes. So melting, freezing, condensation, boiling, evaporation, deposition, sublimation, all physical changes. It's still the same subject at the end that it was at the beginning. Thank you for listening.